there's a lot of theories about from scientists about how it could be basically using the theory of panspermia, which I'm sure a lot of you have to be familiar with, have heard this term before. Panspermia basically is a term for when small bacteria, small life forms can, because they can, and this is a fact, stick to rocks, stick to asteroids that cling into other planets, pick up bacteria from there, and the very small little microscopic bacteria can survive in the vacuum of space. Well, we all know that the creation of life, very complicated how it would have happened here, but also you can simplify it. It uses bacteria to start, in water as well. The soup that made life, so to speak. And basically the theory of panspermia is that since we know that these bacteria can survive on rocks, and that's a fact, then it becomes a theory that if these asteroids have hit other planets that picked up these bacterias, which this is all very realistic so far, only becomes a theory that then those surviving bacteria on the rocks of asteroids that would come in and contact other planets, obviously our own as an example, would then the bacteria would be here. It would be here and it would interact with things on this planet. It'd be in the soil, it'd be in the water, wherever it hit. So, and they look for traces of these bacteria as well, in asteroids, land things. So this is really all just not a far stretch, even though it is a theory, that the only thing that's a theory is that it could have started life in general, and that's the theory of panspermia.
You want to hear something very interesting about the theory of the primordial soup as well?
Yeah, sure.
So, let's see. This was back it's about 2010. About 80 years we had been doing the primordial soup, accepting that theory. But there was a article that was actually explaining that it wasn't necessarily a soup, but more the Earth's chemical energy from like hydrothermal vents that would have
under the water.
Under the water, yes.
Yes.
Yeah, it even says from the vents on the ocean floor, that is what would have kickstarted early life.
Right.
Not an actual, soup.
Right. So under the water, again, that's where life started. I mean, that's just true.
I mean, that makes sense.
Yeah.
Right? I mean, further down on Earth you go,
So that's the theory of panspermia is only a theory and not a truth based on that facts bacteria can survive in the vacuum of space in extreme colds and heat. Facts they can connect themselves to rocks, and rocks do smash into other planets, and that planets break apart, stars break apart. This is how asteroids are flying around in space. All facts. So then the only thing that makes it a theory is that if one hit here, the bacteria is here, that it could have gone into the forming of life. And you use that panspermia theory for life starting in general. But this theory has been attached to octopuses. And I wanted to talk about that a little bit today because a lot of scientists have done a lot of work on this stuff. Back in 2014, they started trying to, dissect octopuses and take a look at their genes, their chemical makeup, their DNA, so on and so forth. And in 2018, papers were released by scientists that run these experiments and said that they found hundreds of genes that did not come from us or any other known animal, insect, reptile, amphibian, anything. Anything that's on this planet, we all share a great deal of chemical makeup that makes all of us work. And there are only slight differences, believe it or not, between us and birds and things like that. They're very closely connected. The octopus is the only thing, octopus and in general cephalopods, the only thing that has completely almost different genetical makeup to them. They have 33,000 protein coding genes. That's way more than humans or any other living creature. And basically protein coding genes is like gene editing, which now with our technology we can try to do. These are things like CRISPR and so on and so forth that we do. But every living organism has some amount of gene editing that they can naturally do. The octopus has 33,000